Alright guys, we are going to talk about CPCTC today. Um, and that's the short of corresponding parts of congruent triangles are congruent. So CPCTC. Up to this point we've already talked about side, 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 angle, side, angle, side, angle, 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 side, and the HL theorem. So all those theorems and postulates that prove that two triangles are congruent. CPCTC does not prove two triangles congruent. CPCTC is used if we're trying to prove two parts of congruent triangles are congruent to each other. Okay? And so we still need to make sure that we have something that proves that two triangles are congruent before we can use CPCTC. So this is just adding an extra element to our proofs, just a little bit more. Okay. So looking at this, again, I've said it, make sure you know that you can only use CPCTC when you've proved two triangles are congruent. Doesn't matter how you do it. If you prove two triangles are congruent, then you can use CPCTC. And now, how do you know if you'll use CPCTC as a reason in your proof? What gives it away? Well, the proof won't be asking for two triangles. Like, it won't say prove triangle, HMK is congruent to triangle HMI. The proof will say prove that KM is congruent to IM. Okay? So what gives it away is the proof will ask about parts, not the entire triangle. Okay, so the proof will ask about parts, not the entire triangle. So let's go through a couple proofs, because my goal for the end of this week is that you guys feel comfortable going through proofs on your own. We'll go through this first one together, kind of walk through the steps and the reasoning, and then we'll go through the second one, which is the CPCTC proof. Alright, so here we go, our normal proof in quotations. So normal proof, the given, it says that angle HMK and angle HMI are right angles. Okay, and then it says that HM bisects angle KHI. Alright, and now we want to prove that triangle HMK is congruent to triangle HMI. So I'll start with my first statement, and my first statement is probably going to be a good idea to use a given. Okay, so I'm going to say that angle HMK and angle HMI and angle HMI are right angles. Alright, and I went too close to the thing, so hopefully you can read it. I'll try to write it bigger next time. Okay, and the reason is just that it's given. Okay, I'll refer to my diagram to make sure that it's marked. So they did do HMI, they didn't do HMK. I'm going to mark it just for good measure so that I can see. I like having everything I've written down marked in my diagram. You should do that as well, just to check over. Alright, something else they told us that HM bisects angle KHI. So what does that mean for us? HM bisects KHI. KHI is this angle. Bisects that angle. That means it cuts it in half. So that means that these two angles should be congruent. Now I've made this marking because I like to have my marks there, but I need to make sure that I write everything I need to in my proof. Okay. So I need to write this given statement here in my proof. HM bisects angle KHI. Okay. It's also given. But that doesn't tell me that I have these two angles congruent. So now I need to say in step 3 that angle KHM is congruent to angle IHM. Okay, and I can say that because, well, it said HM bisects that angle, right? So I'm going to say definition of angle bisector. Okay, that's what an angle bisector does. An angle bisector cuts it in half. That means those two angles are going to be congruent, so I can say that. Okay. All right, so far I have everything I have written marked. I have used the givens. So now where do I go from here? Okay. So if you're looking like I'm looking, you've probably noticed that HM is in both triangles, right? So I'm going to use that and say, hey, HM is in both triangles. It's here. I like to mark it even though it's the same line. HM is congruent to itself. I can say HM and HM. And that's called the reflexive property. Okay. All right. So looking at the diagram now, even without this is why I like looking at the diagram. I can say, hey, these two triangles are congruent. Okay, that's what this says too. So yeah, these two triangles are congruent. Triangle HMK is congruent to triangle HMI. And why is it congruent? Well, I have an angle, a side and angle. The side is included in between my two angles. So angle, side, angle. Okay. I know it's a temptation. You see the right triangle, so you want to think it's the HL theorem. Remember, it doesn't always have to be HL because it's the right triangle. Okay. We can use those two angles congruent to each other because they're right triangles or right angles. Okay. All right. That's our first proof, and that's just using regular old triangle proofs. Notice we did not use CPCTC there because they asked us to prove that two triangles were congruent. All right. Let's look at this next problem. Adjust a little bit so I can get that all in here. All right, just a little bit more. All right, and then hopefully I don't have to do this again. Sorry. Okay, so here we go. There we go. Okay, so now this is the CPCTC proof. Corresponding parts of congruent triangles are congruent. All right, and we can tell that we're going to use that because, like I said before, they're going to ask us to prove parts. So now in this one they said, hey, prove that angle M is congruent to angle N. Okay, remember, kind of giving us a skeleton of what we have to do. We need to prove first that two triangles are congruent. And then if M and N are the corresponding parts of these two triangles, then they have to be congruent because corresponding parts of congruent triangles are congruent because CPCTC. So that's what we're going to be working towards. All right, so let's look at what our given statements are and where we can move from there. They told us that angle MKL is congruent to angle NKL. Angle MKL is congruent to angle NKL. That was given to us. 2. Okay, so MKL, NKL, that's marked for us. 2, they told us that angle KLN is congruent to angle KLM. Hope I'm pronouncing these easy enough for you guys who are looking down at the same time. Okay, and that's also given. All right. Those are our two given statements, so I guess now we have to think on our own a little bit. I can see what I see, I think. We have these two. LK. So LK is congruent to KL. It doesn't really matter. I'll say LK again. And that's the reflexive property. I know it'll matter more when we're talking about our congruent statement. Okay, then remember this triangle is congruent to that triangle. But for the reflexive property, I'm referring to the same segment. Whether I call it LK or KL doesn't hold much weight. It's not very different. Or it's not different at all. I'll say that. That's better. All right, so look at our markings. We have angle, side, angle, kind of the same situation we had as the first example. So I know that my two triangles are congruent, but now it's really important, especially since I had to use CPCTC, that M and N are in the same spot in our congruent statement. Okay, so I don't just want to write them in the same spot. I need to make sure I have the right congruent statement. Before, we really didn't have to worry about that, especially since in our last example, they gave us the congruent statement, and we just had to use it. But now we have to make sure we come up with it on our own and it's accurate. No, did I point to that right? Okay. So let's look at it. We have, this is how I like to do it. I'll go from something that's not marked to one arc to two arcs. So MKL. So I have triangle MKL. That was the pattern I used. Not marked to one mark to two marks. So I'll do the same thing here. In my second triangle, I'll go from not marked in to one mark K to two marks L. Okay. And now these two triangles are congruent, like we said before, because of angle, side, angle. That side is included or in between those two angles, so it works that way. All right. So now we've proved these two triangles are congruent, and that's what we need in order to prove to use CPCTC. Now we don't just use it because it's fun to say. We use it because we're proving two corresponding parts of these triangles are the same. Our congruent statements is triangle MKL is congruent to triangle MKL. And the first thing we learn in this chapter is that in our congruent statements, each angle is matched up with its corresponding angle. Each segment is matched up with this corresponding segment. Okay, so these should be equal if we're saying these two triangles are equal. So then we just kind of point that out. Like, okay, we did that. Angle M then should be congruent to angle N. Okay. Okay, angle M congruent to angle N because corresponding parts of congruent triangles are congruent. A lot faster, right? CPCTC. Okay. Use these notes to help you out with any proofs that you run into, and then think through your assignment for today.